Hi everyone! In this video we're going to talk about calculating standard reduction potential. For particular, we're going to look at the delta E of a cell. So one way we're going to work on calculating this is that E naught for the cell is equal to the E naught of the cathode minus the E naught of the anode. In our textbook and in our note package, we have this data table called standard reduction potentials, and note that it's only reduction, not oxidation. So it tells us the half reaction voltage that we're going to get from just that one half reaction. And the way that we read this is depending on what we have, whatever is the highest number, that's going to be our cathode. So let's look at an example number 1. We have a cell with a zinc electrode and copper electrode. This one I'm just going to tell you is copper 2+, and on your assessment I'll tell you which copper you have. So I'm going to calculate the overall cell potential here. I know that I'm going to have zinc 2+ plus 2 electrons to give me zinc solid. So this is the reduction of zinc. And I'm also going to have copper 2+ and gaining 2 electrons to get copper solid. These are both reduction reactions. They're not happening at the same time. One of them is going to be oxidation in the actual cell, but we're going to first identify which one is the cathode that is going to be reduced, and then we can identify which one is the anode that will be oxidized. So here, in order to figure out which one is the cathode, whatever one shows up first or has the highest number, that's going to be the cathode. So I can see the copper 2+ ion gives me an E naught of 0.34 volts. So I'm going to put that in here. Okay, my zinc, I'm going to look for, I have negative 0.76. So I found copper higher on the list and zinc is much lower, meaning that this is our anode in this example. I'm going to put this into my equation. E naught is equal to E naught of my cathode minus E naught of my anode. I get 0.34 volts minus negative 0.76 volts. I get 110 volts overall. Because I have 2 decimal places here in the subtraction, I know that my final answer needs to have 2 decimal places as well. Over here, I have an example where I have a net ionic equation instead of just 2 metal electrodes. So I'm going to consider the following. I'm going to calculate the standard cell potential for this galvanic cell. First thing I'm going to do is split into half reactions. So I'm going to take, even though I can see this iodide ion here is being oxidized, I'm going to write it as a reduction instead so I know what to look for on my chart. Okay, now I'm going to look for their values on our chart. Okay, looking through, I can see iodine here is 0.54. I don't know yet if this is my cathode or anode. I have to check which one has a higher reduction potential, and that one will be the cathode. So we want bromine, it's right here. That's 109. Okay. This means that this is my cathode and this is my anode, which is true with my net ionic equation because I can see that this is being oxidized. I'm going from something negative to something with an oxidation number with 0. So I'm losing 2 electrons for this to happen to these 2 iodine molecules or ions. In my equation, my E naught is equal to my E naught cathode minus E naught anode. I get 1.09 volts minus 0.54 volts. This gives me 0.55 volts.